All right, ladies and gentlemen, welcome to your video lesson for today. We are going to go over lesson 5.3 in the book, and it's mostly about finding slope of a line. It's an introduction to, or I guess, adding to our understanding of linear equations. When we have straight lines, which is what a linear equation is, we can find the slope of that line, and that's our job today. First, I'm going to go through the warm-up. This is talking about our intercepts method for graphing using the x and y intercepts. Remember, an x-intercept, if I'm going to just draw a coordinate grid here quickly, our x-intercept is where a line crosses the x-axis, and our y-intercept is where the line crosses the y-axis, and those are the only 2 points we really need to graph a line. Obviously, we can use 2 other points on the line. These are the easy ones because, remember, an x-intercept will always have the characteristics that will have some number, and then that y value is always 0. And then a y-intercept, the coordinate will be 0 for x, and then y will be some number. And again, for the x-intercept, that means that, x, it's on the x-axis. I cannot go up or down, so that means y is 0. And I can go left or right, so we have any number for x. Then for the y-intercept, I cannot go left or right, so I have to be on the y-axis. And y can be any number, so I can go up or down and be anything on there. All right. What we do when we use the intercepts method is we use this idea here to our advantage. We say, all right, if I want to find an x-intercept, I'm going to substitute 0 in for y. And if I'm going to find a y-intercept, I substitute 0 in for x. That's what we were practicing last class. So I have these all kind of pre-worked out, so you don't have to watch me write. So I'll go through them. So this equation here, it's already in standard form. It's linear because it doesn't meet any of the disqualifiers, right? It doesn't have x or y to an exponent other than 1. X and y are not multiplied together. X or y are not in denominators. X and y are not in square roots. And what's the other one? X and y are not exponents themselves. So if you see any of those things, any of those 5 things, it's not linear. All of these are linear, otherwise we would be asking you to find the x and y intercepts for them using the intercepts method. Here we go. So finding first the x-intercept. Remember, if I'm finding an x-intercept, I'm substituting 0 for y. Now here's the thing. On all of these, I did the same thing. When I substitute 0 in for y, 2 times 0 is just 0. And so this whole thing wipes out, right? And so that's all I'm left with is 3x equals 15. And so that's all I wrote down for my work, okay? Because if I substitute in 0 for y, it just goes away. So 3x equals 15. If I divide both sides by 3, then I get 5, right? So x is equal to 5. There we go. X is equal to 5. And then I have, remember, it's a coordinate point, right? So I substituted in 0 for y and got x equals 5. So my coordinate point is 5 that I got for x, and the 0 I substituted in for y. All right, finding a y-intercept. So kind of the opposite of what I was just saying. Okay, if I'm finding a y-intercept, that means 0 goes in for x. Well, 3 times 0 is just 0. So I'm left with the small equation, negative 2y equals 15. So negative 2y equals 15 is all I wrote. I divide both sides by negative 2, and I get y equals negative 7.5. So if I substitute in 0 for x, then I got 7.5 for y. That is my y-intercept. I have graphed that here in black. So if we look at the black line, that is my 5, 0 right here. And then 0, negative 7.5 is right there. And there's my line. Okay. In 2, same thing. X-intercept, 0 is going in for y, so I'm left with just the equation because this is going to cross out. Negative 4x is equal to negative 36. Divide both sides by negative 4. I get x equals 9. That gives me a x-intercept of 9, 0. Y-intercept, that means 0 is going in for x, so I'm left with 6y equals negative 36. So I would divide both sides by 6, and I get y equals 6. And so I substituted in 0 for x, and I got 6 for y, so I got 0, 6. That is graphed here in green. So 9, 0 is way over here. 0, 6 is right here, and there's my line in green right there. All right, third one. Now, this one is not in standard form, right? And you don't have to have it in standard form in order to substitute your values in. It's just easier to do that. So I went ahead and did it. I just need to get the 4y over to the other side, right? So I add 4y to both sides. When I do that, I get 8x plus 4y equals negative 56. So now I do the same thing, right? I'm finding an x-intercept. This one's a little bit sloppy just because I have less space, but 0 is going in for y. So I'm left with the equation 8x equals negative 56 because, again, 4 times 0 is 0, so that goes away. So 8x equals negative 56. I divide both sides by 8, and I get 7 for y. Or I'm sorry, 7 for x. So negative 7 for x, and my coordinate point is negative 7, 0. If I substitute in 0 for x, then I end up with 4y equals negative 56. So that's the only equation that I wrote there. If I divide both sides by 4, I get negative 14, and my coordinate point is 0, negative 14. So that is my y-intercept. And so now I'm going to graph negative 7, 0, and then 0, negative 14. It actually goes off the graph. It probably should be somewhere down here, but that's as good as I could get it on what I had here. Last one, again, I had to subtract 3x to the other side this time to get it in standard form. And then it's the same exact process, right? So x-intercept, 0 goes in for y, 9 times 0 goes away. So I'm left with negative 3x equals 18. Divide both sides by 3, negative 3 rather, and I get negative 6. So I have negative 6, 0. For the y-intercept, I substitute 0 in for x. So negative 3 times 0 is 0. I'm left with 9y equals 18. Divide both sides by 9. Y is equal to 2. That to go away. And I have the coordinate point. I substitute in 0 for x, and I got 2. So that one is graphed in red. So I have the point negative 6, 0 right here and 0, 2 right there. And there is my line. So that was that is a lot faster. If I were to do the same thing with like 4 points for each one, I'd be sitting here for another 10 minutes doing that. So that's why the intercepts method is useful. All right, so today's stuff, that was a review. Today's stuff is all about rate of change and slope, okay? So what we want to figure out today is how to calculate slope. We're going to learn how to do it in 2 ways. We're going to learn how to look at a graph and find the slope of the graph or rate of change of the graph. When you hear rate of change and slope, same thing. Okay. Then we're gonna take away the graph. I'm just gonna give you coordinate points or a table, and you're gonna do it that way too. Okay. So first thing here, for a function defined in terms of x and y. So basically all it's saying is like I have a function that is like y is equal to 2x plus 6, right? That function is defined with an x and a y in it. That's all it means. So for a function defined in terms of x and y, the rate of change over part of the domain of the function, that's just like over part of the domain, the rate of change over the x values of the function is the ratio that compares the change in y, in the numerator here, to the change in x in that part of the domain. So that's really fancy to just say like rate of change is the comparison as to how much the y values change compared to, at the same time, how much those x values change, okay? So the table shows the cost of sending 1 ounce letters in the mail, okay? So we have this, it's kind of strange. It's like 2000 and then like X, but it's like 2003, 2004, 2006, 8, 13, right? So this year right here is like 2013. And then we have cents for sending a 1 ounce letter for Y, okay? So if my rate of change is the change in Y in the numerator and then divided by the change in X as a ratio there, well, then if I'm going to go from 2003 to 2004, then what I'm looking at is just this snapshot, right? So the change in X is 4 minus 3. Because as we go this direction, right, as we increase in time, it only went up 1 year, right? And well, and the change in Y didn't change at all. So if I were to write that, it would be in the numerator, the change in Y. Actually, I got this backwards here. What we're going to do. I'm going to rewrite these. Okay, so the change in Y would be 37 minus 37, right? Because that's the Y values. And then the change in x would be 4 minus 3 because it increased in 1. So 4 minus 3, which would give me then 0 change for y over a change of 1 for x. Okay, so that'd be 0 over 1. We'll get back to what that means, right? That means in 1 year, basically, it didn't change at all. So it meant change 0 cents in a year. From 2004 to 2006, maybe I'll use a different color for this one. 2004 to 2006, the change in y was 39 minus 37. And then the change in x was 6 minus 4, which is 39 minus 37 is 2, 6 minus 4 is 2. And we always want to simplify our fractions. So really that is going to be 1 over 1 or 1, which means that between 2004 and 2006, every year it went up a penny, right? Every single year it went up 1 penny. For 2006 to 2008, so now we're talking 2006 to 2008, my change in y was 42. I'm going to get a smaller here. 42 minus 39. My change in x is 8 minus 6, and 42 minus 39 is 3, and 8 minus 6 is 2. So now I have a 3-cent change over 2-year period. 3-cent change over 2-year period. Last one here, I'll do that in black. Boom, boom. And so my change in y is 46 minus 42. And my change in x is 13 minus 8. So 46 minus 42 is 4 cents. 13 minus 8 is 5 cents. And so it's a 4/5 change. So over the course of those 5 years, it changed 4 cents. Okay. So that is how we calculate a rate of change. We find the change in the y value, usually by subtracting the difference. And we find a rate of change in the x, or find the change in x also by subtracting. Then we get our answers from that subtraction, and then we compare what we have, right? And we can interpret it. So we're going to dig a little bit deeper into that on the next slide here. All right, determining slope of a line. It says the rate of change of a linear function be calculated using the rise and the run of the graph of the function. Now, the rise is the difference in the y value. So if we go back to this, right, that the change in y, all of this stuff was the rise. And you can think about it as like the rise in price, right? The price was rising. So the rise is the difference in y values of the 2 points of the line. The run is the difference in the x values. So we have a rise that goes up and down, and we have a run that goes horizontally, how far we go left or right. So the run is the difference in the x values of the 2 points in the line. The slope of the line is the ratio for any 2 points on the line. So it's the ratio of the rise over run. So the slope is rise over run. It is the rise over run. That's how we calculate slope. How much is the change in the rise? What is the change in the run, right? So change in x over change in y. Still that same idea. Now on a graph, it's actually a little bit easier to do this than if I were to just give you a couple points, because all we have to do is calculate that rise over run. Now, a couple things about doing this. First of all, we always read graphs from left to right in this direction, which means if we interpret this slope just for positive or negative value, this slope would be positive because it simply it gets larger as we go to the right. As the x values increase, the y values increase. And so that would give us a positive slope. One way you can think about this is that it is going uphill, right? Uphill, positive slope. If we read this graph over here from left to right, it goes downhill. So this would be a negative slope, okay? Because as the x values increase, the y values go down. So how do I do this on a graph? Well, this right here is my rise, right? So if I'm calculating rise over run, okay, that means I want to figure out what this is. And all I literally have to do is count, right? And I can also look at my y values. I went from a y value of 4 to a y value of 1 to y value of 4. Or I went up 1, 2, 3. Notice the scale here is counting by twos. So I went up 1, 2, 3. So my rise is positive 3 over a run. How far do they go to the right? 1. So my slope equals 3, or you can say 3 over 1. Either way. Move my head here. Look at the next one. All right, so now this one's different because if I count the rise, I have to account for the fact that it's going down. And when it goes down, the rise is negative. I know that sounds weird because rise, we always think of, right? But clearly this line goes down. So you have to think of a negative rise as this line goes down. So the other way to think about it is if I go from left to right, I'm going down. So I'm going down 1, going down 2, going down 3. So this is a negative 3 rise over, and then how far do I run? I go 1, 2, 3, so negative 3 over 3. Now we always want to simplify our fractions. So if you leave it like this, you'll probably lose a half point on a quiz or a test. This is really negative 1, okay? So just make sure that you always simplify your fractions, okay? So when we count on a graph, we count our rise going up or down. If it goes up, it's positive. If it goes down, it's negative. Generally, we count the run going to the right, okay? So applying the same thing to these two graphs here, you should try these on your own. So I'm gonna pause a second, may give you a chance to pause the video and then check what I do. All right, so if you did this on your own, you should have counted up I'm just gonna write right in the graph because it's easier, I got more space. Rise over run. Okay, so first of all, should this be positive or negative? Well, it goes uphill, so it should be positive. So how far do I go up? I go up 1. Again, it counts by 2s, right? 2, 4, 6, 8. So I go up 1, 2, 3, 4, 5, 6. So I go up 6, and I go to the right 1, 2, 3, 4. Now that is a good answer. My slope of 6 over 4 is a good answer, but I have to simplify that. And so my slope is really can't write slope, is really 3 over 2. That would be my simplified fraction. Now, I can use that slope to find the next point on the line. That's what the slope is for. It tells you where to go to get next points on the line. So if I go up 1, 2, 3 again, and then I go right, 1, 2, 3, and I go right, 1, 2, I should get on that line again. And it turns out that I do. Okay. Again, if I go up 1, 2, 3, and I go right, 1, 2, I get on the line again. Okay. So, boom, 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 boom. Oh, I just noticed I made a mistake. All right. So here's the deal. The run is not 4. I miscounted. The run is 1, 2, 3, 4, 5. So when the run is 5, I throw 4 again. When the run is 5, I cannot simplify my fraction. So the slope is not 3 over 2. It is 6 over 5, and that cannot be simplified. When I was doing that, it didn't look like it turned out right. It wasn't right because I was using the wrong thing. So going back to this, if I go up 6, right 5, and if I do that again, up 1, 2, 3, 4, 5, 6, and I go right 1, 2, 3, 4, 5, I get to another point in the line. Okay, so that's what the slope is for. 6/5. My bad about that. Okay, next one. Counting the rise. Now again, this slope, what is it supposed to be? It's going downhill, so my slope should be negative. So what is my rise here? And what is my run? So my rise, I go down 1, 2, 3, 4, 5. So -5. And how far do I run? I run 1. I go over to the right 1. I can't simplify that. So my slope here is equal to -5 over 1. Now you might be thinking to yourself, maybe not, but I'm going to make you think about this. What about if the line is completely horizontal? Okay, so the horizontal line we're going to do in blue here. Okay, so what if I have a horizontal line? Okay, well, think about this. Think about it maybe this way. Would it be positive or negative? Would a horizontal line have a positive or negative slope? The answer to that question is it would not have any of those things because a horizontal line has a slope of 0. All right. Like some people will write down it doesn't have a slope for a horizontal line. That's not true. Um, So a horizontal line has a slope, we can measure it, and it is 0. It's completely flat. And if we were to calculate the rise over the run, think about this, right? I'm rising 0. I can't go up. So let's just pick 2 points. Let's pick this point and that point, right? I rise 0. Okay. And I go and I run, say whatever it is, say 6, right? So my run is 6. I have 0 over 6. If you take your calculator and take 0 divided by any number, you're asking yourself, how many times does that number go into 0? And that answer is always 0, okay? So the slope of a horizontal line is always 0, okay? And that's because the rise is 0. Now, the next question is kind of interesting because it's asking you, well, what is the and all this stuff here. What is the run of a vertical line? So I'll do this one in red. So let's say that this is my vertical line now. Okay. Well, let's pick any 2 points. Let's just pick any point here. Okay. Well, what's my rise? Well, I don't have a particular rise. I'm going to get a little bit narrower marker here. My rise, let's just say I went up 10. Okay. Let's say it was 10. Okay. My run on any vertical line, I cannot go left or right. It's 0. Okay. Now, here's the thing. If you take your calculator and take any number and divide it by 0, you're going to get an error message because what you're asking is, how much does this nothing, this 0, go into 10? And the answer is you can't answer that question. You can't tell me how many times nothing goes into something. It's an impossible question, right? It doesn't make sense. It's an error message. So what we say is that the vertical line slope is undefined. Undefined. Okay, so the slope of a vertical line is undefined. The slope of a horizontal line is 0. Okay, so those are 2 special cases. Vertical line is undefined. Horizontal line, slope is 0, always. All right, so determining slope using a slope formula. There is a formula for slope which we could use when we're not in the graph, but we can verify it with a graph as well. So the slope formula for the slope of a line is the ratio, and it's not anything different than what we've been describing. It's the difference in the ratio, the difference of y values to the difference of x values. Isn't that what we've been saying, right? The change in y divided by the change in x. This is exactly what we did in our warm-up. We took the y values and subtracted them to figure out the change, and we took our x values and subtracted them to figure out the change, okay? Now, this formula looks like it could be complicated, right? It's like an x and a 1 and a y and a 1. But here's what it's doing. It's saying that this is the first point that you're going to use in the formula, and this is the second point that you're going to use in the formula. And then because it's the first point, we're just going to say, well, this is the x value for the first point, and this is the y value for the first point. And then when you get to the second point, you say, well, this is the x value for the second point, and this is the y value for the second point. And so you organize that in the slope formula. And the slope formula is y2 minus y1 over x2 minus x1. So let's see how this works out. Let's first calculate this slope, just like using rise over run on the graph, and then let's prove how the slope formula works here. That's what we're going to do. So if I were to use the graph and count rise over run, so again, these graphs, this one actually doesn't count by 2, so I can count by 1. 1, 2. All right, so if my rise here, just counting rise over run, right? My rise is 1, 2, 3, 4. Okay, so I go up 4, and then I go right, 1, 2, 3, 4. And I have to simplify that fraction, which means my slope is really 1, okay? Now, here's how you'll use the slope formula for that same scenario. This is how I always do it, okay? As I read a graph from left to right, I take those points right off the graph in order. So this is going to be my 1s for my first point. This is going to be my 2s for my second point. So if my formula is that y2 minus y1 over x2 minus x1, my y2 is 3. So I'll start it over here, I guess. I'll say 3 minus, and then my y1 is -1. Now, here's the thing. I cannot change that sign. This has to be subtraction, and that negative has to go with 1. So then my x2, now I have to go back to this one. This is x2, right? So then 2 minus, and then x1, and I can't get rid of this negative, -2. So now if I subtract a negative, it's really adding, right? So I get 3 plus 1, which is 4, and 2 plus 2, which is 4. And lo and behold, I get the same exact thing that I got last time, right? 4 over 4 is 1. Now, if I was on the graph and given the choice, I would not use the slope formula. I would count it. But as you see in our next example, we don't have a graph, right? So now we are forced to use the slope formula. So again, that y2 minus y1, if you're given a table, okay, you can use any set of points. So these are x's and y's. So this is a coordinate point here. This is a coordinate point. This is a coordinate point. That's a coordinate point, okay? So let's go ahead. We're just going to pick one pair, okay? Let's pick the first one and the third one because it doesn't matter, okay? Now, these are my y values. So I'm just going to make this my 1s and these my 2s, okay? And I have to be consistent with that. So my y value, this is my y2. So y2 minus y1. y2 is 6 minus my y1 is 2. Divided by x2 is, I have to go back to this now, 3 minus, and then my x1 is also 3, right? So you're going to see what's going to happen here. 6 minus 2 is 4, and then 3 minus 3 is 0. And we have to think about this, right? Can I actually take 4 divided by 0? And you can't divide by 0. So this is your error message. So that should hopefully trigger a response to you that says, that means that this is undefined, right? It is undefined, which means it's a vertical line. Now let's think about what this would look like on a graph. Let's just think about these 2 points. I'm just going to sketch this briefly. If I graph the point 3, 2, so let's say 3, 2 is here, and now I go graph the point 3, 6, it's right on top of it, right? That gives me a vertical line, and that tells me this matches up with what I understand that line to be and the slope of it to be. Awesome. All right. So 2 more examples here. I have these kind of pre-done already. So find the slope of the line passing through the given points, and using the slope formula, describe the slope as positive, negative, 0, or undefined. So table, right? So we have to use the slope formula. So I have to pick any 2 points. I am choosing, what points did I choose under here? I am choosing those 2 points. I'm going to pick these as my 1s on the left, and I'll pick these as my 2s. So that means my y2 is 5, and my y1 is also 5, okay? So then in my denominator, I'm just going to get rid of this. My denominator, my x2 is 4. My x1 is 2. So I have 4 minus 2, right? These are the points that I'm using here. I'm just going to make it more obvious. And so 5 minus 5 is 0, and then 4 minus 2 is 2. And again, I have to make a decision here. 0 divided by how many times does 2 go into 0? 0 times. It cannot go in at all. So again, let's make sense of what this looks like on the graph. If I were to graph the point, say 5, 2 is here, right? And then 5, 4 might be here. That would be a horizontal line, which makes sense with what we know about a horizontal line and the slope being 0. Okay. Next one here. On the graph, so I could count this, but I want to use the slope formula. We can verify it with the graph itself. This one, 2, 4, so this does count by 2s. So I'm actually just going to use the slope formula here. As I use the graph, this is going to be my 1s here. So this is my first point. This is my second point. That means my y2 is going to be -5. So I start off with -5 minus y1, which is 9. And then I have my x2, which is 2, minus -1. So I can't get rid of the signs here. 5 minus 9 is -14. 2 minus -1, that's really addition. That gives me 3, and that can't be simplified. Here's what I also do not want. I do not want you to say that this is like 3 2/3 or 4 2/3, okay? I don't want you to turn it into a mixed number. And when we get into graphing more later, you're going to understand why. It's kind of an unusable number. All right, I'll do one last example for you here. What if you're given coordinate points, not on a graph, not in a table? Here's what I would do. Pick the first point to be your 1. So I'm going to just label this straight up. X1, Y1. Y1, I'm sorry, Y2, X2, Y2. So then my formula is Y2, 16, minus Y1, which is 4, divided by x2, which is -1, minus x1, which is -5. That gives me 16 minus 4 is 12. -1 minus negative, I'm just going to change this right away. So now it's like -1 plus 5, which is 4. And I actually have a slope. I have to simplify this full credit. That gives me a slope of 3. All right. That means if I graph these 2 points, the slope between them would be 3, which means I can go up 3, right 1, up 3, right 1, up 3, right 1, and create that line. All right, a couple word problems here, and then we're going to be donezo. It says find and interpret the real-world slope for the real-world situation. For the graph on the right shows the relationship between the person's age and his or her estimated maximum heart rate. So I don't know if you know this, but as you get older, your maximum heart rate depletes. Like when I was training used to do some crazy runs. I used to do like some ultra marathons. I have recorded maximum heart rates using my heart rate monitor in the 190s. That's really high. And that was when I was in my mid 20s, late 20s, 30s. I'm 38 now, and I can't get my heart rate to go above 170. So it probably has something to do with a little bit less training. But anyhow, this is true. Your maximum heart rate decreases as you get older. So we have 2 points on the graph here. So we have age in years on the x-axis. We have maximum heart rate, which is measured in beats per minute. So the 60 here is beats per minute, 60 beats per minute. So anyhow, we can see that the line goes down, right? So again, as I'm figuring out what the slope is, I would treat this as my first point. This is my second point, which means this is my x1, y1. This is my x2, y2. And now that I have it labeled, it makes the rest of it kind of easy. So I'm going to just get rid of this box. That means my y2 is 150 minus 180, which is my y1. 50 minus 20 in the denominator for x2 minus x1. 180 or 150 minus 180 is negative 30. 50 minus negative 20 is 30. So I end up with a slope of -1, right? So if my slope is -1, think about, again, we have to reinterpret this, what this means. That means, and again, if I write it in a fraction, it helps. Because what does my numerator represent? It represents my y values, which is beats per minute, right? And what does the denominator represent? Well, it represents my age in years. So let's just say years, right? What that means is my beats per minute go down per every single year. So beats per minute goes down once, one value, per one single year. And that's exactly what I have down here. This means that every year a person's maximum heart rate drops 1 beat per minute. All right. Last problem here. It says the cubic feet of water, Y, so Y is being measured, Y is a value of cubic feet of water in a reservoir after X hours. The water starts flowing into the reservoir as a linear function. So we have water flowing into a reservoir. We're measuring it in hours and in cubic feet, right? So time is measured in hours. The amount of water in the reservoir is measured in cubic feet. And so we have time that is going by as water is pouring in. So that means that this is my X value. This is a coordinate point that is marking those measurements. So this is X, this is Y, right? Well, if X represents hours and Y represents cubic feet of water, it says explain what the points 43,000 means in the context of this problem. Well, 40 hours, it'd be 40 hours, and this would be cubic feet of water. So what that means is that after 40 hours, there is 3,000 cubic feet of water in the reservoir. Okay. Same thing, explain what 64,000 means. Well, it's the same exact meaning for X and Y, it's just different numbers. So now that means that after 60 hours, there is 4,000 cubic feet of water in the reservoir. And now we want to find that rate of change. So we got our 2 coordinate points here. Again, I would call this, I'm just going to label it because I hadn't before. This is going to be X1, Y1. This is going to be X2, Y2. Okay? So as I do this, that means I'll have 4,000 minus 3,000 over 60 minus 40. 4,000 minus 3,000 over 60 minus 40. That gives me 1,000 cubic feet of water over 20 hours. And if I simplify that further, that gives me 50 cubic feet of water per hour. And that is the last question I have to answer here. What does that slope mean in the context of the problem? This means that every hour, 50 cubic feet of water goes into the reservoir. That's what that means. All right, hopefully this video was helpful for you. I hope you guys are doing well. We are approaching the end of the semester, so grind, ladies and gentlemen. Grind, grind, grind. Get it done. Take care. Peace.